The final topic that we'd like to look at in terms of the NewtonCotes integration is this idea of open methods. So in some cases we don't know what the values of our function are at the endpoints, and this can occur in a number of cases. For example, if we're trying to do an improper integral, in other words where one of the points lies at infinity or negative infinity, or when one or both of the values are singularities, in other words they're infinite, and also in the solution of ordinary differential equations that we're going to look at later on in this unit. So we don't always have the data values that we might need at the endpoints, but that doesn't stop us from using the NewtonCotes idea. So let's have a look at the case of 4 points, and imagine that we only know the values at the middle points x2 and x3, and we don't have the values at x1 and x4. We can still fit a straight line to the 2 points where we do have data values. And we can approximate the integral as the area under this line, integrated from x1 to x4. So that region there. Basically, this becomes, in effect, the trapezoidal rule, but we're integrating over 3 segments, and we're only using the 2 inside function values. What's this truncation error compared to the Simpson's 3/8 rule? Well, it's significantly higher. But it still gives us an approximation. There are a number of open formula, and they're all based on higher order polynomials. You do not need to remember these. If you have to use them, they will be given to you. This is just a list for segments going from 2, 3, 4 and 5, where we have extracted both of the points at the end. So for 2 segments, we're only using 1 point in the middle, and we're fitting a constant. For 3 points, we've just looked at this one. For 4 points, this is sort of like a version of Simpson's 1/3 rule, except we're now integrating over 4 segments instead of 2 segments. And this one down here is like a version of the Simpson's 3/8 rule, except now we're integrating over 5 segments, but we're only using 4 points. It is also possible to derive semi-open formula. In other words, one end is missing and the other end is included. We're not going to do that in this unit. If you wanted to use open methods in practice, what you would do is you would divide your interval into a number of different sub-intervals. You would use the open method only at the endpoints, and you would use the closed methods for all of the interior points where you had all of the information. So the open methods typically will only be used at the ends of your domain. So to summarize the key points from the NewtonCotes idea, the NewtonCotes formula come from fitting a polynomial to the data points and integrating the polynomial analytically. And we approximate the actual integral with the polynomial integral. One of the most important things to remember is you will never use a single application of any of these NewtonCotes formula. You would always use the composite methods, and certainly if I say to use one of these methods, I will always mean the composite method, even if I do not say so. The other thing that you might want to remember is this idea of closed methods versus open methods, and when you might use open methods versus closed.